to reuse. And that was the solution we pursued. How many AWS services could we kind of cobble together along with a bunch of open source technology to try and deliver this thing really fast? And so this is the architecture we came up with. And I'm not going to walk you through every box here, but I will point out the sort of relevant AWS parts of the architecture. In the top middle, you'll see a horizontal kind of long rectangle. That's simple queue service. Basically, users specify jobs, pages to be rendered. Those pages, when they need to be rendered, get put into SQS. The three sort of square boxes below that are EC2 nodes running in various AWS data centers that pluck work out of that queue, go render the pages, and then they take their data that they get from rendering those pages and put it into one of the data stores to the right. They're rendering pages in full browsers, so Internet Explorer, Firefox, et cetera. They put screenshots of what they actually rendered into S3. They store the full HTML and all the other associated files in S3 as well. They put performance data into SDB. And they put some relational kind of performance data used for alarming into RDS. The nice thing about this is S3 is basically a bottomless pit in terms of a file store. So normally storing large numbers of screenshots and all the content from these pages would have been a challenge, but it's pretty easy here. You'll also see at the top we use CloudWatch. Obviously, our users want to generate real-time graphics or real-time graphs of the performance data of their web pages, and CloudWatch makes that easy. Way over on the right side, you'll see an arrow going down that says notification. At the time we built this application, there was no simple notification service, so we had to roll our own. But in the future, we will be migrating this application to use SNS. So the results of this were pretty cool. First of all, we built this application in a couple months with very few developers. Would have been impossible to do had you not had all those very primitive services to build on top of. The second thing is, and this is a big one for me, doing an external monitoring application would have previously required me to go negotiate a whole bunch of colo deals with third-party providers. For us, that's amazingly painful. I'd have to go talk to the tax department, the legal department, security department, finance, and a bunch of other people that I would rather not spend my day talking to. And so it would have been just incredibly complicated to negotiate all those deals. Whereas with AWS, you just simply call an API and you can tell it where you want your servers to be. We get true external performance metrics because the AWS network is like a completely separate independent client network from the Amazon retail network. We can also test site features before they're released. This is pretty cool and wasn't one of our initial features, but we realized was possible after the fact. Because we know the IP addresses of the EC2 hosts that we've provisioned to do this remote rendering, we can allow them to tunnel through to our development environment. So we can do pure client-side metrics on features that haven't even launched to the world yet. And that would have been impossible before. The final thing is the system scales really easily to large amounts of data. S3 is a bottomless pit. SDB is also mostly a bottomless pit. And RDS, you can get very big instances that run RDS, so it becomes pretty easy to scale your application. But the use case everyone wants to really know about is Amazon.com web servers, right? That's the kind of the big thing. It's the biggest fleet of servers at Amazon, and so everyone wants to know how we're using that. So in 2009, we started thinking about how to use it for Amazon.com. And the reason is this graph. This is a typical weekly traffic graph from Amazon.com. As you can see, during the peak of the day, there are lots of people hitting the Amazon.com website, and at night, there are significantly less people hitting the website. And one of the great promises of AWS, right, is this flexible capacity. You only need to buy what you're going to use. So I spent a couple years of my life trying to predict this red line. And the red line on this graph is the expected peak for the week plus 15%. We add 15% just to account for sort of unexpected traffic spikes or sales that we might have on the site. And it generally ended up being a pretty good safety margin. But if you're observant, you'll notice that there's a large amount of area between the red line and the blue line, right? And that area is servers that I have bought, but I'm not using, right? And that's bad. Like if your goal is to sell things really cheaply to customers, which is what our goal is, like large amounts of waste is not a way to achieve that goal. So if you actually calculate the area that we're wasting during a typical week, it's about 39%. We were wasting 39% of our capacity. And frankly, that's pretty darn good. There are very few businesses out there that only waste 39% of their capacity. We were pretty proud that we'd gotten it to that point. But our problem is actually way worse than that, right, because of this graph. This is traffic to the Amazon.com website in November, right? And during the course of the month of November, shopping on the Amazon website ramps up significantly. And again, you see that there's this red line, expected peak plus 15%. And if you calculate the area on this graph, you'll find that in the month of November, we're wasting 76% of the web servers that I'm paying for as the owner of the Amazon.com website. And the problem is really actually worse than that, because there's so many servers that we have to rack to deal with this sort of spike in capacity that we have to start before November, right? And then after the peak passes at the end of in December, I'm stuck with those servers anyway, right? Even though I don't need them in January. So the problem is really significantly worse than this shows, but this is good enough for our purposes. So the problem here is pretty obvious, right? We're wasting tons and tons of hardware. And when we waste tons and tons of hardware, it means we need to price items higher than we otherwise would on the Amazon website, and that's bad for our business. Secondly, dealing with traffic spikes requires heroic effort, right? If my 15% safety factor doesn't account for the amount of traffic that's going to spike up, well, then I have to go figure out other systems I can deprovision to throw them into the web server pool and all kinds of other horrible things that you don't like to do at on weekends or late hours of the night. And then the final thing is scaling is nonlinear. Amazon was a big site in 2009, and I didn't buy hosts in ones or twos, right? I bought racks at a time, and a rack for me was 40 servers. But I have an availability, a model that had 3 data centers. So when I buy a rack in one data center, I actually buy 3 racks, right? One for each of the data centers. So I was buying servers in units of 120, right? And so even though I might only need 1 or 2 more hosts, I buy 120 because that's the way it is. But there's an even worse part to that, which is at some point I put the last rack in a data center that can fit there, right? And the next rack basically costs $10 million. Oh yeah, and it takes a year and a half to get it, right? Because you got to do all the tax and legal and building, and it's all horrible. So the solution seems very, very simple when you write it on a PowerPoint slide. Well, we'll just migrate the entire Amazon.com web server fleet to AWS. We'll just do that this weekend. So we did come up with a way to do this, right? And this was the architecture that we came up with to enable this type of model. The customer comes in from the left. They hit the Amazon.com old school data center to one of our old load balancers that we've bought. We own lots of these things. May as well keep using them. That load balancer takes the request, funnels it across VPC to web servers that we've spun up on EC2 in multiple availability zones in the AWS data center. Those web servers run the exact same software that our web servers used to run in the Amazon.com data centers. We used to run Linux in Amazon.com data centers. We now run Linux in AWS data centers. If those web servers need to talk back to the Amazon.com data center to either get to databases or services that they might need to talk to, that's fine. VPC makes this seamless transition across this network boundary. Anyway, ultimately, those web servers get the content they need to render the page. They form an HTML page. They send it back through VPC to the load balancer, which returns it to the customer. And this is a pretty important date for Amazon.com because November 10th, 2010 is the day that we turned off the last physical web server serving Amazon.com. Since that date, there's not been a single web request served by a physical web server in the Amazon.com data center. Every single request has been served out of AWS on our EC2 fleet. So if you go to hit Amazon.com today, you're talking to EC2. Some people might say, wow, that's kind of crazy. You did that in Q4. But it is kind of crazy, but there was a lot of money to be saved in the ramp up at the end of the month that you saw there. So it was perhaps crazy, but also crazy like a fox maybe. So what were the results of this? Well, first of all traffic for Amazon.com is now served from AWS, web servers in AWS. We can dramatically scale the fleet in increments as small as a single host whenever we want, right? There's simple API calls. I no longer buy 120s, I buy 1s, 2s, or 3s. And traffic spikes now can be handled with ease. If we do have a sudden spike, well, we just spin up a bunch of EC2 instances and it makes it really, really easy. So one final use case before we end here. Because I know a bunch of you are concerned about databases and how you can use or not use AWS in terms of databases, so I thought it would be fun to pull out one. And so now we're in the year 2011, and we'll talk about this page on the Amazon website. If you go to the order history page in the Your Account section of the website, there's this thing here that allows you to view any web order or any order you have ever placed on Amazon.com. And Amazon has this, we use the word promise a lot internally. We make a promise to customers that you will always be able to view any order you have ever placed on Amazon.com, and that will always be the case. The problem is that as you might imagine, over the years on Amazon.com, people place lots of orders, right? Billions of them, in fact. And so the